So
Sounds
welcome
good.
everyone. Thanks so much for joining us on this very exciting night. My name is John Lach. I'm a professor in electrical and computer engineering, and I'm the director of cross-cutting initiatives for the engineering school.
And I'm Laura Barnes. I'm an assistant professor in systems and information engineering.
And we're really excited to tell you about some of the things that we have going on in the world of smart and connected health, and to explain the role of cyber-physical systems in sort of enabling this vision of the future where we have literally trillions of things out there, and as part of our Internet of Things, that are all going to be connected together, and a good number of them are going to be focused on health and really empowering people to get better control of their own health. So we're going to be talking to you about some of those activities here today. But first, I'm going to tell you about my mom. So my mom, when she was about 70 years old, she was diagnosed with systemic scleroderma, which is it's an autoimmune disease that's a hardening of soft tissue. So for her, it primarily affected her lungs. So as the disease progressed, her lung capacity dropped, and she became weaker and weaker and ultimately passed away from it. As an engineer who works in the health space, developing technologies for health, I got to tell you, it was pretty frustrating at times to see my mom struggle with this really difficult disease and not being able to do anything about it. But now let me tell you about my dad. So my dad, Fred, was the 24/7 caregiver for my mom for years. As she became weaker over time, he was just there. He was stepping up. Really pretty amazing. I didn't know he was capable of some of those things, but he did it for my mom, and he did it because he loved her, and he wanted to keep her living at home as long as he possibly could. And he was a trooper throughout. But in the last couple of months of my mom's life, the oxygen deprivation from her reduced lung capacity really started to affect her brain and her cognitive functioning, and started to exhibit signs of dementia. And one of the things that's really common with people who have dementia is some behavioral issues, especially in the form of agitation. Where they start behaving in ways that make it very challenging for the caregiver. And in fact, so my dad, he never once complained for all those years as my mom's 24/7 caregiver, but those last few weeks when my mom was up at night, she was verbally abusive at times, acting in ways that was just unrecognizable, because of the sort of dementia related behaviors. It really kind of, that's what started to wear down my dad and started to make him feel like he could no longer care for my mom at home. And we, for the first time, started to have a conversation about transitioning, my dear mom, they had been married for almost 50 years, from living at home with him to a care facility. And it turns out that dementia-related agitation is the #1 reason why families transition loved ones with dementia from living at home to a care facility. So I don't know if any of you have had to deal with these kinds of issues, and families and friends being caregivers. The families want to be able to care for their loved ones, but can find it so difficult to do so. And so I'll be coming back to this in a little bit to talk to you about how cyber-physical systems and smart and connected health is going to help people like my dad going forward.
Thank you. And so how do we help people like Fred Lach? So let's talk about what smart and connected health is and where we're at today. So how many of you have ever felt like a statistic when you go to the doctor? Most of the treatments only help a handful of people. So we're designing treatments for the population, which may not really be effective. So how do we move towards this vision of smart and connected health that's focused on the person more than the population level? So traditional medicine, we have irregular clinical examinations, medical imaging, inpatient monitoring, laboratory results, and maybe genomics. So how do we move away from this and actually have more of an individualized treatment? So we have all these devices. I don't know how many of you have smartwatches. We all have smartphones, I'm sure, in this room. These are medical devices. They generate patient-generated data that can tell us a lot about behaviors, our patterns of daily life that can be used to ultimately individualize medicine and make better decisions. And so what are these data streams and what can they tell us? So these different sensors that we wear, the devices we carry and use in our everyday life can tell us about cognition, our activities, our communication, what's our social network like? How much do we work? Our access to green space and the environment, our mood, and ultimately we can use this to individualize treatment. So behind the scenes, you're taking that data and using machine learning and analytics tools to actually optimize treatment. So going from population level to more of an N=1 individualized treatment. And so to that end, one project, big area we're working on is mental health and how do we optimize treatment for mental health. So mental health problems, especially on college campuses, are very pervasive. A lot is understood about the physical illness, but not a lot is known about the mind. And 1 in 4 people will have a mental illness. 50% of people will experience one at some time in their life. However, only 1/3 of these people actually seek treatment. If they were actually to seek treatment, there wouldn't be enough help out there to actually give it to them. So we need more scalable options, and that's where smart and connected health comes in. And so we look at our digital footprints, our devices, the footprints we leave as being able to create insight into our mental health and link our behaviors, our personal characteristics, and our environment to health outcomes. So can we use these, our question is, how can we use these to create a digital safety net and be able to optimize our health and wellness? And so we're working, one particular project we're working on is monitoring of social anxiety. So social anxiety is, anxiety disorders are the most common, second to depression, disorder that we experience, individuals experience, especially on college campuses. And so these are disorders where you have very difficult time with social interactions or any potentially socially evaluative situation, and it's a vicious loop. So that fear influences your future behaviors. And so treatment of that is very important to be able to optimize somebody's daily interactions and help them deal with that fear. And so speaking about it from the CPS perspective, we have this sense, detect, predict, and intervene framework, which can characterize a lot of the work that's going on in the Link Lab. But looking at data streams from smartphones is our predominant focus. So can we use those data streams, like our phone accelerometer data, to tell us something about our anxiety symptoms, about our different environmental context, our activities of daily living, who we're talking to, how many interactions we have. So mapping these diverse data streams to those symptoms of social anxiety to be able to detect shaky hands that someone might be able to experience before or after a social interaction, rapid heartbeat, excessive sweating, a shaky voice. So taking this sensor data and using it to predict health, some health outcome that ultimately can be used to optimize treatment. So can we see if an intervention is working, looking at change of anxiety over time, somebody's stability or rhythm of daily life, is that changing? Our mood, are we going to be socially isolating ourselves as a result of a social interaction? And ultimately, we take this data and use it to optimize interventions. So we're looking at how can we optimize when, how, and what intervention to deliver. So I'll pass it back to John to talk about some of our other projects.
Great, thanks, Laura. So one of the key questions that often comes up as engineers are talking about these health applications is what exactly are we doing from a technical perspective to enable these kinds of applications? And so just to sort of take you through some of the core technical capabilities we have here in the Link Lab that we've assembled in the Link Lab by bringing all these people together. On the sensing side, we have some core competencies in low power circuit and system design, wireless communication and networking, building that Internet of Things that we've talked about. And then human factors is such a critical part of this. We can build the coolest technology in the world. If people don't use it, it's not going to be effective. From detection and prediction, a lot of this involves some necessary advances in signal processing, machine learning, other data science techniques. And then these notions of cloud and edge computing. All this computation needs to be done somewhere. What should be done out there at the edge? What should be centralized in the cloud? What are the trade-offs involved? And then in terms of the intervention, so a lot of cyber-physical systems is in the realm of control. How do we actually control and optimize something? And there's sort of different methods that we have for that: model-based control, data-driven control. Safety critical system design and analysis, as you can imagine, with the kinds of applications that we're targeting, is really, really important here. We need to know that when we're intervening, we're doing so in a safe and effective way. Security. I mean, you think about issues of security and privacy for these kinds of systems, especially as it does turn into these trillions of things that are out there, becomes a huge challenge that we have to address from the beginning. It's not something we can just add on later. And then human factors again. Are we intervening with these humans in an effective way? So tying this back then to some other examples of systems and applications. So Laura was telling you about one, and you know, some of the things that we're doing here on the sensing side: wireless, mobile technologies, sensing capabilities, large scale, these, which is in all the challenges that come at those scales, multimodal sensing, lots of different kinds of sensing that's involved, and also self-powered systems. That's something that we've been looking at recently too, where, you know, we're going to have, you can't just have all these batteries. I mean, think about how often you charge your cell phone, right? I mean, we're going to need something where we can harvest power from the environment to have these run forever without being charged. In terms of detection, we're doing a lot in areas such as eating and behaviors around that, stress, critical health events, being able to really detect those and actuate appropriately. Falls is another thing that we've looked at. Looking at falls in the elderly is a really, really critical issue, and so developing some methods for that. And then prediction. As Laura mentioned, prediction is a really critical component to this. It's, you know, it's one thing to detect something, it's another thing to predict it and ultimately prevent it. So thinking about unhealthy behaviors, other types of critical events, and then falls. As we started working on falls, we quickly realized, you know what, we're better off preventing the falls than we are trying to detect them. And then in the interventions, amazing projects that we have with the artificial pancreas, or looking at family eating dynamics and how that relates to a propensity for childhood obesity. Biofeedback, giving people more information about themselves and their own health. Coordinating with emergency response systems, physical rehabilitation, or you saw as part of the video there what we're doing with some people who do robotic surgery. There's a great demo around the corner over here that actually shows the robotic surgery system, and we're going to be having those surgical residents come over and work with us on that. So back to my dad and my mom. So based on everything I told you, you probably have some ideas yourself of what could we do to actually help caregivers of people with dementia. Again, caregiver burden associated with dementia-related agitation, the #1 reason why family transitions loved ones from living at home to a care facility. So let's think about this here. Well, we have this project underway here, collaborating with some people in geriatrics and human factors. And one of the things that we want to be able to do that we've learned through these collaborations is that agitation is typically this ramp-up thing. It's not something that goes from 0 to 60 instantaneously. There's some fidgeting and some other sort of subtle aspects of agitation, both in their motion and in their vocalizations, that precede the more dramatic kinds of agitation. So can we sense motion and vocalizations for the dementia patient? Also the environment and the context around the patient, and really trying to understand the relationship between the context and the environment and agitation. So we built this sensor system that combines lots of different things. Some of them are wearables, some are sensors that are around the house, all wirelessly connected together so we can do real-time analysis and be able to detect those early stages of agitation. We've shown that we can do that. Or to identify causal factors of how the environment and the context could actually lead to agitation, and by monitoring the environment, we can develop those types of predictive models. And then these then lead us to be able to intervene. If we detect the early stages of agitation, real-time notification to the caregiver so they can intervene before agitation escalation, when those soothing interventions can still be effective. And then if we're actually able to develop these predictive models, if we identify some causal factors and then we recognize those again in the future with our sensing capabilities, we then can send a notification to alter the environment or the context before the agitation has even begun. It's empowering the caregiver, making them feel more in control, and hopefully giving them the confidence that caregiver self-efficacy is one of those phrases we use that makes them feel like they can care for their loved ones at home for a longer period. Okay. Now, Laura and I are a couple of engineers, but I can tell you on all these projects we're talking about, it's these big interdisciplinary teams. The Link Lab has brought together people from lots of different engineering disciplines, but if it were just engineers doing it and just kind of building something and say, well, that's cool and be done, we wouldn't have any impact. So these are some of my collaborators here in geriatric psychiatry, geriatric nursing, human factors, and all of our students coming together on this kind of project here. And that's really one of the special things that we have here at UVA. So on this wonderful grounds here. So there are 300, depending on how you count, there are 368 engineering schools in the country. Only 21 of them have engineering schools and medical schools that are both ranked in the top 40 in the US News and World Report. Only 8 of them have the engineering school and the medical school within a mile of each other. That kind of co-location is truly priceless when you're trying to build these kinds of collaborations and projects. We couldn't do it without them. So the kinds of interactions that you've been hearing about tonight that we're having here in the Link Lab, we're extending that all across grounds, and especially over in the School of Medicine, the School of Nursing, the Psychology Department. We're working with architecture and just all over grounds. It creates those kinds of opportunities that really enable us to solve these societal grand challenges and have the impact that's going to make a difference in people's lives. So thank you so much for hearing a little bit about what we have going on here, and look forward to any questions you might have.
Questions?
Oh, yeah, please.
So, and again, this is personal because my mom has dementia too. So is this agitation something that's common across dementia?
It's,
or is it for some, topical?
so it's a subset, but if one of my collaborators were here, they'd be able to tell you what the actual answer is. But it is. Oh yeah. So yeah, the how common is agitation in dementia patients? Does it tend to affect a certain subset? And it does. But it's something like 50%. It's a big number. I wish I could give you the exact percentage, but it's a big number. And again, it's. When I first started collaborating with these people and trying to understand the issues related to dementia and aging in place, I sort of expected that it would be some safety issues, wandering, some things like that. But no, it was caregiver burden associated with dementia-related agitation, the #1 reason why families transition their loved ones. Yes?
I imagine that telling someone that you're going to connect their entire supply of data to the internet, it makes them unwary. How do you assure people that are going to be part of these systems that their information is safe?
That's a great question. You want to take
Yeah, so I think the biggest thing we start with is trying to demonstrate the benefit of the study. While there might not be an immediate benefit with the research we're doing, we have to show them the benefit that could be potential down the line by them actually participating and sharing their data. And also we've started thinking about, can we give them something back in the meantime? Like looking at their mood over the week, to look at potential stressors, for example. Another thing is ensuring them that their data is secure, and protections that we will take to secure their data. So all of our work is approved by an institutional review board that looks at data protections and our consent form and makes sure that we're not overlooking something. So.
Yeah, it's a really important question, and in fact, I mentioned that that one of the things that we monitor in the dementia project are vocalizations of the dementia patient. We do have microphones in the room, but we do not record the audio. We do the processing there locally and extract features from those signals. And we store those features and we process on those features so that there's no recording of what's actually being said. So those are some of the technical steps that we can take. But as Laura said, it ends up being sort of a value proposition when we think about privacy. And privacy is a moving target. It's a social construct, and it's totally different now than it was 5 years ago. And it's totally different in the US than it is in Europe. And so this is something that just needs to be part of the conversation as we go, and people need to know what they're signing up for. Right.
And it's really, to add to that, it's really dependent on the group you're working with, how they view it. So college students, for example, are in an era that they're willing to share a lot more. But we're talking about an elderly population, it's completely different.
Interesting, when you talk about feature extraction, okay, my background, biometrics, pattern recognition, I recognize that. I was surprised you're not using something like deep neural networks and feeding different voices. Okay, this patient with stage 3 Alzheimer's. You feed trains out of over and over again, and then eventually it says, okay, let's feed this in. What is it? This computer predict what stage he's in.
Yeah. So.
Also,
We are, yeah. So we have this, so there's so many of kind of various processing techniques in the field of data science, machine learning, all of that can be brought to bear on this. And then, but some of these problems, especially some of the sensor fusion problems with this heterogeneous data that we're collecting, require new data science solutions. And fortunately, we have it. We have the colleagues here to be able to explore those kinds of things. So yeah, I mean, it's really interesting as. So data science researchers are always looking for data and interesting problems, and Laura and I are generating a ton of it. And Laura's actually an outstanding data scientist herself. And so it's really finding these partnerships. So I'm a data generator, and I need people who can make sense of it. That's right.
Yeah.
Yes.
What are your next steps with your project?
With the Dementia project? So right now we are actually next week, I think we are doing our last deployment in the phase 2 of our first study, where we're just monitoring at this point, and we're analyzing our algorithms for agitation detection and this prediction based on environmental and contextual monitoring. And then starting in about 2 or 3 months, it's going to be the first deployments where we are automatically doing these real-time notifications to the caregivers based on our models. And we'll see. I always tell my students, they're right in the back here, I tell my students that at some point in time, we're going to hit go and stand back and say, I hope this thing works. But that's part of the challenge. We're really getting ready for that. And so the first 2 phases of our study so far have been about, developing the sensor system, developing and doing everything we can to validate our algorithms and our detection and prediction capabilities. But we want to get to that point where we hit go and we start to send these notifications. And ultimately from that, if we see some benefit, we're going to get, and the number one outcome for that study is caregiver self-efficacy. It's their assessment of their own ability to care for their loved one. And if we get some good initial feedback from that, that's then going to lead to a larger human subject study where we deploy this system in many homes for extended periods. Yeah, Mike.
John, I'd assume that you would do some kind of co-evolution with some of the early caregivers you test to see what things work better for them, or you just have to kind of roll it out to pick up whatever.
Yeah, that's a great question. So the question was, how is it that we engage with these caregivers and their loved ones? We call them dyads, the caregiver and the person with dementia. They're partners in this research project with us. I mean, one of the things that Laura said about the privacy issue is that, these people, they're volunteering to do something that they know is still very much in development, that they might personally not see a huge amount of benefit, but they know what their experience is. And I mean, this is one of those things that warms your heart about humanity, right? These people volunteering to be part of this. Their lives are tough enough as it is, and now they're inviting us into their homes because they know that it has the potential to be helping people in their situation down the line. And they're part of the study, and they are providing their impact. They're providing their input along the way. I mentioned one of our primary collaborators is a human factors expert, and it's constantly how do we solicit that input so it can feed back in to shape the direction of the research. Any other questions?
Have you found that existing sensors are giving you the data you need, or do you have to design your own?
A little bit of both. A little bit of both. So this is where we engage people like material scientists who are developing new kinds of sensing capabilities. In fact, one of the demos that we have here right next door is on a self-powered implantable sensor that is running off of flows in the body. This is particularly airflow through the trachea, and we're having to use some piezoelectric materials to harvest the energy that is generated by that airflow through the trachea. And so we're using that as the energy harvesting source and the sensing to see, if this is for an asthma application, to see how airflow through the trachea is changing over time. And so those are things like, we are starting from materials, and then building devices from that and so on. But we also don't like reinventing the wheel. And so if we can use a smartphone or an off-the-shelf smartwatch or something like that, we will. We're actually using some off-the-shelf smartwatches in the Dementia project, and I think you are as well. And
So both, yeah.
So it's both, yeah. Well, thank you so much.
Thank you.
This has been fun.
Yeah.
Good opportunity.